Hi guys, welcome to lesson of ordinary differential equations. So in the previous classes, we discussed non-exact equations that are reducible to exact, and we discussed 4 cases. Now we are going to discuss case number 5. So case number 5 is for the type of equations that are given x to the power m, y to the power n, where m and n are integers, times ay dx plus bx dy plus x to the power m prime, y to the power n prime, where m prime and prime are also integers, time a prime y dx plus b prime x dy is equals to 0. So if we have an equation of this kind, then we can simply find the integrating factor by m plus h plus 1 over a is equals to n plus k plus 1 over b, and then m prime plus h plus 1 over a prime is equals to n prime plus k plus 1 over b prime. So by using these equations, we can find h and k, and then the integrating factor may be given by x to the power h and y to the power k. So this is the idea of these type of equations, and we'll take some examples to understand what's going on here. So let's take this example, that is y cubed minus 2x squared y times dx plus 2xy squared minus x cubed dy is equals to 0, right? So first of all, take this into standard form. So we can take y as common here, or we can write in this way: y cubed dx minus 2x squared y dx plus 2xy squared dy minus x cubed dy is equals to 0, right? And then again, we can write it in this way: y squared times y dx plus 2x dy, that we have taken this and this for dx and dy, and to make it in the standard form, and then plus x squared times negative 2y dx minus x dy is equals to 0. And now we can compare this equation with the standard form. So we have x to the power 0 here and y to the power 0 here, and here we have y dx and x dy and y dx and x dy, right? So we just need to uh, uh, yes, we just need to find these m and k and l, so h and k, sorry. So m is equals to 0 because here it's x to the power 0, and n is equals to 2, and then a is equals to 1 because the coefficient of y here is 1, and then b is equals to 2, right? Here it's 2. And then we have m prime is equals to 2, n prime is equals to 0 from here, right? And then we have a prime is equals to -2, and 3 prime is equals to -1. Now put this in the formula, so we can write here 0 plus h plus 1 over a, that is 1, is equals to n plus k plus 1 over b, that is 2. And here we will have 2 plus h plus 1 over a prime, that is -2. And that is equals to 0 plus k plus 1 over -1. All right, so now we can find h and k from here. So this will be 2 times h plus 1 is equals to 3 plus k. And from here we have negative h negative 3 is equals to negative 2k minus 2. So we have two equations. We can solve for h and k. So we'll have the equation from here, 2h minus k is equals to 1. And from here we will have h minus 2k is equals to -1. And solving both the equations, we will get h equals 1 and k equals 1. Right, so the integrating factor in this case will be x times 1 and y times 1, that is equals to xy. So we just need to multiply the whole equation by xy, and we will get this equation xy 4 minus 2x cubed y squared dx plus 2x squared y cubed minus x to the power 4y dy is equals to 0. And we can simply check that dou m over dou y is equals to 4x y cubed minus 4x cubed y, and dou n over dou x is equals to 4x y cubed minus 4x cubed y, and both are equal, right? So now the equation is exact and we can apply the definition of exact equation. So we just need to integrate the function, apply the integral x power 5 to x cubed y squared, where y's are constant here, and then plus we have 2x squared y cubed minus x to the power 4y dy, where sorry, dy here, so it's dy and it's equals to 0. And we know that for the exact equation, here every function of x is 0 wherever the function x is involved, so this will be 0. And here y is constant, so it will be constant, and we can simply integrate. So we will get x squared y to the power 4 over 2 negative 2x to the power 4 y squared over 4 is equals to c. And here we will get 2x squared y4 minus or simply yes x, sorry, here we can just cancel this 2 with 4 in the second term. 2 1s are 2, 2 to the 4, so we will get x squared y4 minus x4 y squared is equals to c. And this 2 when multiplied by c is c again, because it's a constant, we can write it c, right? So in this way we can solve these equations, and we can write it in further simplified form: x squared y squared into y squared minus x squared equals c, right? So let's take one more example. This is the answer to get more concepts for this particular case. And this is 3y minus 2x y cubed dx, and then plus 4x minus 3x squared y squared times dy is equals to 0. Now, first of all, we need to convert the equation to the standard form, and then need to find the integers and that constants. that we need. So we can write 3y dx minus 2x y cubed dx plus 4x dy minus 3x squared y squared dy is equals to 0, right? And now we can write this equation in this way: 3y dx plus 4x dy, this one with this one, and then we have plus, or we can write minus, uh, we can take commons here. So what we can take common is y squared. So xy squared you can take as common. So you'll take xy squared outside, and we will left with 2y dx plus 3x dy is equals to 0. Right. And it's better if we shift this, we keep this positive and shift this negative sign inside, so it will be negative 2y dx negative 3x dy. It will be better because we need to assign these positive negative signs to the constants. It's necessary. So here we can see this is x to the power 0, y to the power 0. So m and n both are 0, right? A is equals to 3, b is equals to 4. Here m dash is equals to 1 because of power 1. N dash or n prime is equals to y squared. A prime is negative 2, b prime is negative 3. And now apply the formula, that is m plus h plus 1 over a is equals to n plus k plus 1 over b. Right, and m prime plus h plus 1 over a prime is equals to n prime plus k plus 1 over b prime. So we need to apply this formula, and we will see that we will have 0 plus h plus 1 over a, that is 3. And then we have 0 plus is equals to 0 plus k plus 1 over b, that is 4. So we have the equation 3h minus 2k is equals to 0. And from here we will have 4h uh, minus 3k plus 1 equals 0. So this is equation 1. Say this is equation 2. We can solve both equations to find the values of h and k. So we will just simply solve these equations simultaneously, and we will get h is equals to 2 and k is equals to 3. So the integrating factor will be x squared y cubed. Now we need to simply multiply with the differential equation that is given, and we will get 3x squared y to the power 4 minus 2x cubed y to the power 6 dx plus 4x squared y cubed minus 3x 4y 5 dy is equals to 0. Now we can see that this equation is exact, so we need to apply the definition of exact equation to solve the problem simply. So here it's dx and plus here this will be 0 because x is everywhere in the equation with dy. So this will become 0 0, right? So we need to integrate this part keeping y constant. So we will have 3x cubed y to the power 4 over 3 minus 2x power 4 y 6 over 4 is equals to 0. 3 and 3 cancels, 2 2s are 4, and so we will get 2x cubed, and here we will get c, constant of the integration. So 2x cube y4 minus x4 y6 is equals to C. This is the answer for this problem. So in this manner, we can solve these problems. And these are the 5 cases. We can inspect the given problem, that whatever case is applicable, we can apply the cases, and then we can make the equation exact, right? And then in the next class, we will discuss about the differential equations that are reducible to exact by inspection method. And we will also take some problems, particular problems to that case. And then after that, we will start the linear first order differential equations. Thanks for watching the lesson, and goodbye.